Hi, I'm Hungry Frank, and I'll be taking you through Auto Tractor. So, on the Auto Tractor, we shall start with the hydraulic system. Let's start by defining what a hydraulic system is. We see a hydraulic system is a technology where a fluid is used to move energy from an electric motor to an actuator such as a hydraulic cylinder. In this case, the actuator, which is the hydraulic cylinder, is connected to the load of which it is the implement in the tractor or an attachment. Yeah, a tractor is used to carry out particular work using those attachments or implements, and these implements are run by the hydraulic system. So the fluid which is used, the hydraulic fluid in this case, should be incompressible in order to avoid power losses. So we could look at examples of implements. Now implements, these are attachments used to do work. For example, in the fields, in farming, we have the plow, we have the digger, which is used to dig into the ground. We have a cultivator, we have planters. So all these could be classified as under implements. Other examples of components which use the hydraulic system, we could see the steering system that also uses the hydraulic system. We have the brake system, we have the gear shifting system, in this case which is the gearbox changing the gears. Then we have the clutch system. All these components, they also use the hydraulic system. Let us look more on the hydraulic system. We have components of the hydraulic system. One is the reservoir. The reservoir is basically to store the hydraulic fluid. It's where you top up the hydraulic fluid in case it is less, and it stores in excess in case the system needs more fluid. It's where the fluid is drawn from. We have the hydraulic pump. The hydraulic pump moves the liquid through the system and converts mechanical energy converts mechanical energy and motion into hydraulic fluid power. So the pump is basically to move the fluid throughout the system. Then we have the electric motor which powers the hydraulic pump. So we have the valves also. The valves control the flow of the fluid and relieves excessive pressure from the system if needed. The valves, we could have directional control valves. These change the direction of flow of the fluid, and they can also close the system to stop the flow of fluid. Then we could have pressure relief valves in case the pressure is high in the system. These valves could help in relieving the pressure, reducing the pressure. Then we have the hydraulic cylinder. The hydraulic cylinder basically converts hydraulic energy into mechanical energy. This is where now the load is connected, the load of the tractor. It's connected at the hydraulic cylinder, so that when the pump pushes the hydraulic fluid, it is converted into mechanical energy to either lift or lower the implement or attachment in this case. So the hydraulic system on a tractor consists of two conditions. We have the two circuits, the high pressure circuit and the low pressure circuit. The high pressure circuit operates at a pressure of 250 bars. Now this is a lot of pressure, so in order to accommodate all this pressure means we would need a bigger system. As we see in this case, we have the implement. Our implement, it's a big one, so it would need more power, more energy to lift and lower the system, and it runs at a flow rate of 8 liters per minute. Then we have the low pressure circuit, which operates at a pressure of 30 bars with fluid flow speed of 20 liters per minute. Now these are smaller implements, as we saw in the first case in this slide. we have these smaller systems. They don't need a lot of energy to operate, so they use the lower pressure circuit. The tractor hydraulic system is classified into two. We have the open loop system and the closed loop system. Now, with the open loop system, the inlet and actuator ports they come from the reservoir, which is the oil tank. In this case, when you look at this point, this is the inlet. This is where the pump draws the hydraulic fluid from to circulate it in the system. Then we look at the return port. This is now from the motor where the work is done. Both of these ports come directly from the oil tank, which means this system, the fluid moves through the system and returns to the tank. Now, in an open circuit system, in an open loop system, we have the directional control valves. We use directional control valves. Now, these ones are basically used in changing the direction of flow of the fluid. In this position, we can see that the valve has closed the system. The fluid is not flowing in this position. So if we turn the valve in the upper position, when you take a look at these arrows, we have one going this side. So when we flip the valve in this position, we have the fluid going in that direction through the motor to perform the work, and then it moves back to this point, and when you look at this second arrow, it is returned back into the reservoir. So that is one direction. Then when you flip the valve in the opposite direction, in this case this point, when you take good look at the direction of the arrows. Let me first erase this a bit to give us a cleaner. So when you look at the direction of these arrows, now in this case we are trying to change the direction of flow of the fluid. So when you flip the valve in this position, you look at this upper arrow, it will move from this point to that point. So the direction now in this case will be in the opposite direction to the first case. So the liquid will pass through the motor, which is our load, in a different direction. So which means the direction of motion of the work of the load will change. And when the fluid reaches this point again, when you look at the second arrow, it is the tube is switched back to this point, such that now we have the fluid moving down back to the reservoir. So in an open center system, we have a fluid moving back and forth through the motor, and the valve, the directional control valve, is used to change direction of the fluid. So we shall look at the second classification is the closed loop system, which are also called hydrostatic drives. In this system, the fluid does not return to the reservoir from the motor. It instead loops back to the pump to be reused in the system. So when you look at this is the inlet. So the pump is drawing the fluid from the tank, and it moves in that direction through the pump to connect to this tubing. Then it is pumped through the motor to do the work. Yeah, so we have that it's pumped through the motor to do the work. In this case, the motor is connected to the load, and then after the fluid does its work, in this case, remember in open loop system we said the fluid returns to the reservoir or the oil tank. Now in the closed loop system, the fluid does not return to the tank. It instead loops back and is taken again back to the pump such that it is reused in the system. Yeah. Then we have a bypass in this case. In case the pressure is too high, this bypass, the component here detects the charge pressure. In case it is too high, then the fluid is bypassed. The fluid bypasses the pump and it is returned back to the oil tank. But this is only when the pressure is too high. In normal working conditions, the fluid moves through the pump, goes to the motor, does the work, and then it circulates to the pump to be reused in the system. So in closed loop system, we have the fluid moving throughout the system. There is a continuous motion of the fluid in the system. It's not taken back to the oil tank. So in this case, we may not need a big oil tank. We just need a the pump to just draw the fluid for once, and then the oil tank is just used as a reservoir for in case the liquid runs low. So let's look at the choice of selection. When you're choosing between these two systems, there are factors to consider. One is the cost involved in the system. The cost is like in open loop systems, we require additional components like directional control valves, unlike closed systems whose controls are in the pump. Now in the closed loop system, let's go back to this drawing. We have our pump. Remember, in open loop systems, we say that the direction is controlled by the directional control valves. In the closed loop system, the controls are in the pump itself. We have a displacement controller which is attached to a swash plate. We shall look at this in the subsequent lectures. So the direction is controlled within the pump itself. That's where you control the direction of fluid flow, whether in the opposite direction or in the normal direction. So in this case, we may save in the closed loop system, we save on the money which would have gone into purchasing a directional control valve, and the tubing also we use less, so there are fewer components in the closed loop system. Then we have complexity in construction. In the open loop system, we have the fluid which has to pass through the control valve, the directional control valves, then it goes to the motor, and then it's returned back again to the the directional control valve. So it's complex in terms of construction and would require many components. Then we look at the degree of precision required in the system. Now with this, we have in closed loop systems are used in machinery which needs precise control. Let's say the excavator. Now the excavator needs, when the operator has control of the arm in doing the work, so it needs to go in a particular direction with high precision. Like when I need to pick dirt from a given point, I have to control the arm of the excavator to that given point, so I need to have control of the arm. So we could say that the closed loop systems are used in in systems where we need precision, whereas the open loop system, we don't need precision. When we go back to the implements, most cases, the garden implements, the farm implements, they use open systems, because in that case we just need to lift the implement up and down. There is no precision required in this case. It's just either up when the tractor is not doing work, and then move the implement down for it to start doing work. So we don't need precision in that case. Then we look at energy losses within the system. When we talk about energy losses, we look at components. How many components are in the system? Of course, in the open loop system, we have extra components like the relief valve, directional control valves. We have more pipes running here and there. So the more components you have, the more energy is lost within the system. But for closed loop system, we have direct movement of the hydraulic fluid from the pump to the motor, to the load. So the fewer the components, the less energy which is lost in the system. So in the next presentation, we shall look at power takeoffs and how power is distributed within these implements, and how energy is transferred from one component to the other. Thank you. Bye.